So this module is going to talk a little bit about the application layer. So the application layer is the layer that deals with the end device. Regardless of whether you're the source device or the destination device, the application layer is either the first one you interact with, or during de-encapsulation, it is the last layer before getting to the end device to be processed. So the upper three layers of the OSI model, the application, presentation, and session, define functions of the TCP/IP application layer. And again, remembering that the upper layers are usually regarded as software layers, while the lower layers are regarded as hardware layers, because once you get to the network layer, and the data link and the physical, the bottom layers, you are dealing with actual physical equipment. So your application layer provides the interface between applications used to communicate and the underlying network over which these messages are transmitted. So it is communication between applications from the source and the destination. It is still a peer-to-peer communication, but not a physical peer-to-peer communication. It is via the application. Some of the most widely known application layer protocols will include HTTP, FTP, TFTP, IMAP, and DNS. So please go back and refresh if you have forgotten what port numbers are associated with which ones. So briefly, let's go over it. Domain name system, 53, HTTP, 80, or the optional of 8080. Simple mail transfer protocol, port 25. Post office protocol, 110. DHCP is 67 and 68, one for the client request and one for the server response. File transfer is 20 and 21, one to establish a connection and the other one to push the data. And then Internet Message Access Protocol, this one I always forget. I don't want to misspeak, so you're going to have to relook that one back up. I don't use it that often, so I always forget what the port number is associated with it. Now, your presentation layer has three primary functions: formatting or presenting data at the source device into a compatible format for receipt by the destination device. So, when you're thinking about presenting, how does it look? Is it a movie? Is it a video? Is it a JPEG? Is it a GIF? What is it? And at the destination, can that file be readable at the destination? Does the data have to be compressed in such a way that it can be decompressed by the destination device? And are we encrypting our data for transmission and then decrypting data upon receipt? So when we talk about the initial synchronization between the source and destination, these are the different parameters that they will be discussing. If I want to encrypt, which encryption method do we both use? Okay, if I'm going to compress, which compression method do we both use? Okay, so things of that nature. Your session layer is there just to create, maintain, and then terminate dialogues between those applications. Excuse me. So it handles exchange of information to initiate dialogues, to keep them active, and to restart sessions if something happens. So again, when you're thinking about initializing dialogues, you're thinking about that synchronization, a preamble to get that connection up and going. Keeping them alive, there was a little thing we called a keep alive signal that would be sent between the two to keep that channel open. And then if for some reason something were to happen, we have to restart or reset that connection. That is the functionality of the session layer. Now, your TCP/IP application protocol or those protocols specify the format and control information that is necessary for many common internet communication functions. Your application layer protocols are used by both the source and the destination during a communication session. For the communication to be successful, the application layer protocols that are implemented on the source and destination must be compatible. So again, when we talk about these port numbers that we're going to go over again in the next couple of slides, so you will be tasked with having a brief description of these protocols, so a small functionality about how they work, what protocol they use, and the port number specific to them. So again, going back to the conversation and establishing a connection. So if the source is going to initiate a conversation using port 53, then it has to make sure that the destination has that port open and ready to receive a conversation on that port. So DNS, domain name system. It uses TCP or UDP. It is port 53, and it translates domain names such as cisco.com into IP addresses. DHCP, Dynamic Host Control Protocol, Host Configuration Protocol, uses 68 for the client request and 67 for the server response under UDP. And what DHCP does is dynamically assign an IP address to be reused when it is no longer needed. HTTP, Hypertext Transfer Protocol, ports 80 or the alternate of 8080. It is a set of rules for exchanging text, graphic images, sound, video, and other multimedia files on the World Wide Web. SMTP, Simple Mail Transfer Protocol, utilizes TCP on port 25, and this enables clients to send email to a mail server or enables servers to send email to other servers. POP3, Post Office Protocol, TCP utilizing port 110. It enables clients to retrieve email from a mail server. It downloads the email to the local mail application of the client, and then that mail is deleted. IMAP 143, I almost said 143. IMAP, Internet Message Access Protocol, utilizing TCP with port 143. This enables clients to access email stored on a mail server. However, the difference between POP and IMAP is your IMAP server will maintain the email on the server until you yourself delete it from the server. File Transfer Protocol, TCP, ports 20 to 21. It sets rules that enable a user on one host to access and transfer files to and from another host over the network. FTP is a reliable, connection-oriented, and acknowledged file delivery protocol. Its flip side to that coin is TFTP, Trivial File Transfer Protocol. It uses UDP with port 69. It is a simple connectionless file transfer protocol with best effort unacknowledged file delivery. It uses less overhead than FTP. So don't forget what the words connection-oriented and connectionless mean. Connection-oriented means reliability. It's going to establish that connection, keep it up for the time of the conversation, do all the reliability within TCP, where UDP is just going to, hey, say, I'm going to send this file. I'm not going to establish a connection. I don't know if you're even there. I'm just going to send it. Maybe you'll get it. Now, we talked about these different models way back when in the first session or two. Client-server processes are considered to be in the application layer. The client begins the exchange by requesting data from the server, which then will respond by sending one or more streams of data to the client. In this client-server model, the device requesting the information would be the client, and the device responding to the request is called the server. Application layer protocols describe the format of the requests and responses between clients and servers. And we'll see that in another couple of slides coming up. One thing to take note, if you have a client-server model where you can have one server hosting multiple different services, so this server here in this picture could be doing web browsing, email, file transfer, all on one server. The disadvantage to a client-server model is if that server goes down, it is 1 point of failure. If that server goes down and is utilizing multiple different services, no one gets any of those services that are running on that server. So that is a definite downfall. Now, in your peer-to-peer network, in a peer-to-peer P2P, 2 or more computers are connected via a network and can share share resources such as printers and files without having that dedicated server. Every connected end device, known as a peer, can function as both a server or a client. One computer might assume the role of server for one transaction while simultaneously serving as a client for another. So the roles of client and server are set on a per request basis. A P2P application allows the device to act as both a client and a server within the same conversation. So some applications will use a hybrid system where each peer accesses an index server to get the location of a resource that is stored on another peer. Both clients can simultaneously send and receive messages. So something similar to this would be you doing an instant message. You and someone else where you can actually send and receive at the same time. Common P2P applications. With P2P, each computer in the network that is running the application can act as a client or a server for other computers in the network that are also running that same application. BitTorrent is a communication protocol for peer-to-peer file sharing. It enables users to distribute data and electronic files over the internet in a decentralized manner. Direct Connect is also a file sharing client and protocol used by the program AOL Instant Messenger. eDonkey, also known as eDonkey 2000 Network or D2K, is also a popular file sharing network application or protocol, excuse me. And then Freenet is a peer-to-peer platform for censorship or censorship-resistant communication. There are a plethora of P2P applications out there. It uses Freenet uses a decentralized distributed data store to keep and deliver information and has a suite of free software for publishing and communicating on the web without fear of censorship. Now, way back when, one of the first things that started to be shared was music. So, dating myself, I'm going back to a program called Kazaa. So, if you had Kazaa and I had Kazaa, I would open up my Kazaa and I would share whichever music I wanted to share. You would do the same. So if I were looking for a song, I would search that song and you would come up and perhaps other servers would come up. And then your device would do exactly what we do in the human network when we are tasked with trying to either buy a car, purchase an internet service. Okay, we compare. Your devices compare. Who has the faster speed, who has the more reliable, connection, if that's what you're looking for. So they would do that. That conversation would be open for the time of that transfer, and then again, terminated at the end of the transfer. So breaking them down one by one, hypertext transfer protocol and hypertext markup language. When a web address or a uniform resource locator, a URL, is typed into a browser, the web browser establishes a connection to the web server. To better understand how the web browser and web server interact, we're going to examine how a web page is opened in a browser. So down in the corner here on the client, that client has typed in www.cisco.com. Now, what you should see immediately in your browser is when you hit that enter key, now you'll see http www.cisco.com/indexed and then the backslash, I'm sorry, .html. So the browser interprets three parts of the URL. So the URL has three different parts. It has the protocol or the scheme that is identified by HTTP. It has the server name, which is www.cisco.com, and then it has the specific file name that you are actually requesting. That file name is, in this case, an HTML file, which is hypertext markup language, that has the code to display www.cisco.com. Okay, so that index.html is the specific file name for the web page that will display cisco.com. So step 2, the browser then checks with the name server to convert www.cisco.com into a numeric IP address, which it uses to connect to the server. So this is where you see DNS in play. The client initiates an HTTP request to a server by sending a GET request to the server and asking specifically for the index.html file. Step 3, in response to that request, your server will send the HTML code for the web page to the browser. And then step 4, the browser will decipher the HTML code and format the page for the browser window. So, you kind of saw this early on when you went through Wireshark and you went through the steps and you were looking for the get, the push, and the pull, different message types in HTML. So that's what you did earlier on. So within HTTP and HTTPS, which is the secure version that utilizes port 443, okay, the three common message types are the get, the post, and the put. The get is a client request for data. A client web browser sends the get message to the web server to request those HTML pages. The post is when this uploads data files to the web server, such as form data. The put is when it uploads resources or content to the web server, such as an image. So a slight note here, HTTP is not a secure protocol. If you need secure communication sent across the internet, you should always use HTTPS. Excuse me. So email protocols. Email is a store and forward method of sending, storing, and retrieving electronic mail across an internet or a network. Email messages are stored in databases on mail servers. The clients then communicate with these servers to send and receive their email. The email protocols which are used for this operation are both Simple Mail Transfer Protocol, SMTP, which is used to send mail, and then Post Office Protocol, POP, as well as IMAP, Internet Messaging Application Protocol, I believe, used for clients to receive mail. So when you're looking at this graphic here on the right-hand side, the sender has to have a correct email address to send to. So that is going to be the recipient's name at whatever website or email you're going to. So in this case, it's a recipient at cisco.com. So when the source generates the information, it is utilizing STMP. So what happens is within STMP, the first ISP mail server will get that request. Okay, so it utilizes STMP. Oops, I'm sorry. I'll explain it here. My bad. I can't go back when I'm recording, unfortunately. So when well, I could, but I had to record it over. I'm just going to do it here. So when a client sends, the client SMTP process connects with the server SMT process on well-known port 25. So again, from the source, okay, the sender is going to generate an email here. Okay, you have to have a complete valid email. So that's going to get sent. Oh, I'm sorry, I didn't even see this one. So that's going to get sent via SMTP utilizing port 25. Okay, so what happens is the first server gets it, and the question at the server's destination is, do you have a mailbox for this recipient? If you do, you would forward the mail to their mailbox. If you do not, you send it to the next server in line. The next server in line, or from the previous server to the next server in line, you are also utilizing SMTP. Okay, so client to server, SMTP, server to server, SMTP. So SMTP, client to server, and server to server. Okay, very important to know the differences. SMT message formats require a message header, which would be recipient's email and sender's email, and a message body. Now, POP is used by an application to retrieve mail from a mail server. When mail is downloaded from the server to the client using POP, messages are then deleted on that particular server. The server starts the POP service by passively listening to TCP port 110 for a client connection request. When a client wants to make use of the service, it sends a request to establish a TCP connection with that server. When the connection is established, the POP server sends a greeting. The client and POP server then exchange commands and responses until the connection is closed or aborted. Very important concept, POP does not store messages, so it is not recommended for small businesses that need a centralized backup solution. So again, I did it again. Sorry, guys. So again, client to server, SMTP. Server to server, SMTP. Client downloading from a server using either POP or IMAP. So IMAP is another protocol that describes a method to retrieve email messages. Unlike POP, when a user connects to an IMAP server, copies of those messages are downloaded to the client application. The original messages are also kept on the server until manually deleted by you. When a user decides to delete a message, the server will synchronize that action and will delete the message also from the server. So again, hopefully I won't mess this one up. Client to server. server to server. Client downloading. The messages using POP. Okay, messages are deleted. Oops, I'll try and spell that right. So messages are deleted on the server. Okay, client downloading using IMAP. Okay, the server will keep the message until we delete it. Biggest difference between the two. Now, DNS, domain name service. Domain names were created to convert the numeric IP addresses into a simple recognizable name. Fully qualified domain names, FQDNs, such as http://www.cisco.com are much easier for people to remember than knowing that cisco.com is 198.133.219.25, let alone Cisco being so large, having multiple different IP addresses. The DNS protocol defines an automated service that will match resource names with the required numeric network address. It includes the format for queries, responses, and data. So let's not get confused. DNS is created by the administrator. It is on us. So every organization has internal DNS servers, okay, that we define. We define the mapping. So as you're coming up from the main entrance and you see that kiosk, that scroll and mapping at the very beginning, that is bound to an IP address, okay? So your DNS server sends out a DNS query. It can also get a DNS query response from the server itself in the second picture here. And then lastly, the client will utilize 198.133.219.25. Message formats that you need to know within a DNS server. It will store different types of resource records that are used to resolve names. These records contain the name, address, and type of record that exists. So a capital A is an end device IP4 address. A capital NS is an authoritative name server. So an authoritative name server is the server that was able to answer the request. For capital A's is an end device IPv6 address, pronounced a quad A. and MX is a mail exchange record. So when a client makes a query, the server DNS process will first look at its own records to resolve the name. If it is unable to resolve the name by using its stored records, it will contact other servers to resolve the name. One thing you need to understand about DNS is that it is global in nature. After a match is found and returned to the original requesting server, the server will temporarily store that numbered address in the event that the same name is requested again. And of course, we see this all the time in networking, where information is sent, but it will be held for a small period of time, usually based on the operating system in play. Just in case that same action is going to happen again, you don't have to start from square zero. So DNS uses the same message format between servers, consisting of a question, an answer, the authority, and additional information for all types of client queries and server responses, error messages, and transfer of resource record information. So the message section for a question is the question for the name server. The answer is the resource record that is going to answer that question from the server. The authority is the resource record that will point toward an authority. And additional information could be resource records that hold additional information. Now, as I stated previously, DNS is global. It is a root system, much like you see in DOS or Bash or any of those nowadays that we will utilize in command structure. So at the very top level is your root level domain. So DNS again uses a hierarchical system to create a database to provide name resolution. So if you don't know what hierarchical means, it means you have a top level and then you break it down from there. IP addressing, subnetting is also hierarchical, because when you think about it, and to put this and that into context, when you get an IP address, the all-inclusive network address is a .0 as an example. So this is the top of the hierarchy here. Now, if I decide to subnet, don't worry about the numbers, I'm just going to do this as an example. Oh, it's not the example. Back up for 1 second here. Okay, so if I've decided to subnet out my network, now I get my subnets. My .0 with the slash of, I'm going to say 27, because in this example I'm going to borrow 3 bits. This one would be the .32. And this one would be the .64. Okay, now I would go down and I would say here, my devices are going to be between .1 and .30. Okay, here, .33 to .62. And likewise here, .65 to 94. Okay, this is hierarchical. It starts here, we go down a level to get here. We're here, we go down a level to get here. That is a hierarchical nature. Same thing with DNS. So you have your root level domain. Then you have your top level domains. So your top level domains are your actual extensions, I'll call them. So your .nets, .edu, .com, .au, .co, which represent countries. You could have, as you see there, .org, .gov, whole bunch of different things. .com, okay? These are your top level domains. From there, and using Cisco as the example here, within cisco.com, now this is your second level domain. Within cisco.com, I have www.cisco.com for web browsing. I have ftp.cisco.com for file transfer, and I have mail.cisco.com for our mail service. Okay, so hierarchy nature. So each DNS server maintains a specific database file and is only responsible for managing name to IP mappings for that small portion of the entire DNS structure. When a DNS server receives a request for a name translation that is not within its DNS zone, the server will forward the request to another server within the proper zone for translation. Now, if I want to look up information having to do with DNS, the command to use in the Windows operating system is nslookup. This is going to allow a user to manually query the DNS server configured on a device to resolve a given host name. So I think you also did a lab like this way back when, where you tried to either ping or web browse two different server locations. This utility can also be used to troubleshoot name resolution issues and to verify the current status of the name server. So when the DNS lookup command is issued, the default DNS server configured for your host is displayed. The name of a host or domain can be entered at the nslookup prompt. So here I did nslookup on my PC, and I get my default server, which is sj.cisco.com. So Cisco resides in San Jose, just in case you didn't know. And the address for that is 171.70.168.183. www.cisco.com is the same. Okay. The origin is www.cisco.com, and these are the addresses within. You also have aliases. And then you can have cisco.neticat.net. And that is the same address, however, for cisco.com, but cisco.netiquette.net has its own address of 72.163.6.223. So the main is the cisco.com or sj.cisco.com. So you see all three of them have that address as the hierarchy, okay? And this is the address for that. Okay, however, when you go down deeper, www.cisco.com is this address. Okay, and netacad.net at Cisco is this address. So that is that hierarchical structure that you're seeing here with the nslookup command. Now, dynamic host configuration protocol. DHCP for IP4 service automates the assignment of IP4 addresses, subnet masks, gateways, and other IP4 networking parameters. It is considered dynamic addressing compared to static addressing. However, do not misunderstand, we, the administrators, have to define the parameters of DHCP, of the DHCP pool. So it is still done by the administrator initially. Okay, so we create a pool, we tell our pool, or we tell our device how many IP addresses we're willing to give up in our public pool. Once we do that, and then, I don't want to say turn it on, but establish it and it's functioning, then it takes on dynamically from there. whereas static addressing, as we should know by now, is manually entered by us. So when a host within DHCP connects to the network, the DHCP server is contacted and an address is requested. The server chooses an address from a configured range of addresses called a pool and assigns it a lease time. So that lease time would be something that we would do within our parameters of the pool. Many networks use both DHCP and static addressing. DHCP is used for general purpose hosts, such as your end user's devices, but static addressing is used for network devices such as our gateway routers, our switches, our servers, our printers, an admin's address so that it doesn't always change if you're trying to remotely log in, so things of that nature. Within DHCP for IPv6, it provides similar services for your IPv6 clients. However, it does not provide a default gateway address. This address can only be obtained dynamically again from the router advertisement, where in that advertisement, the router says to use its own default gateway address or its own address as your default gateway. So the process, and you need to know the process of how this works. So I always use, for those of you who might have small children at some point or had small children at some point, even though I did, my kids never watched Dora the Explorer. So remember Dora the Explorer. Little Dora. Okay? Dora the Explorer will help us to remember what happens. So, the discover, the offer, the request, and the acknowledgement. You need to know this for your certifications and going forward. So when an IP4 DHCP configured device boots up or connects to the network, the client will automatically broadcast a DHCP discover message to identify any available servers on the network. A server would then reply with an offer, which offers a lease to the client. If a client receives more than one offer due to multiple servers on the network, just like we talked about earlier when you're picking a car or picking a service, your device will choose what it wants to accept. The client will then send a request. That request is for the IP configuration information. So the message received is identifying the explicit server and lease offer that the client is accepting. The server then returns an acknowledgement that acknowledges to the client that the lease has been finalized. If the offer, so if the client, if the end device takes too long to accept the offer may expire, just like in real life, kids. The offer may expire and you may have to start the process again. Okay? If the offer is no longer valid, the selected server would respond with a DHCP negative announcement, a NAC message, and the process must begin with a discovery message again. DHCP 6 has a set of messages that are very similar to those for DHCP 4, but when we're talking about the stateful DHCP 6 server, those messages are solicit, advertise, information request, and reply. Excuse me. FTP, file transfer, was developed to allow for data transfers between a client and a server. It is an application which runs on a computer that is being used to push and pull data from an FTP server. So step 1, the client establishes the first connection to the server for control traffic using port 21. The traffic consists of client commands and server replies. And that is simply to establish a connection. Step 2, the client establishes the second connection to the server for the actual data transfer using TCP port 20. This connection is created every single time there is data to be transferred. Step 3, the data transfer can happen in either direction. The client can download, which is to pull data from the server, or the client can upload, which is to push data to the server. So pulling, I'm downloading, pushing, I'm uploading. There is also server message block. So SMB is a client-server request response filing sharing protocol where servers can make their own resources available to clients on the network. There are 3 functions within SMB: start, authenticate, and terminate sessions. Control file and printer access. It allows application to send or receive messages to or from another device. So, unlike the file sharing supported by FTP clients, they establish a long-term connection to the server. After the connection is established, the user of the client can access the resources on the server as though the resource is local to the client itself. So that is a little bit about your application protocols. You do need to know the acronym, what the acronym means, a basic overview of the protocol, which transport layer protocol it uses, TCP or UDP, and which port number.